Hello friends, welcome back to our channel Aha Zindagi Edu-Care. This is the sixth lecture of matrices. Till last lecture we have discussed what is matrix, types of matrices, then operation of matrices, under which we have covered addition, subtraction, scalar multiplication and multiplication of two matrices. After that we have seen how to calculate trace of a matrix and properties of trace of a matrix. We have also discussed transpose of a matrix and its properties. So those who have not gone through previous lectures of matrices, please follow the link given in the description box. Okay friends. So today we are going to discuss adjoint of a matrix, cofactors, properties of adjoint of a matrix. Then we will see how to calculate inverse of a matrix using this adjoint formula. We will also see properties of inverse of a matrix. Okay friends, so let's start with adjoint of a matrix. Adjoint of a matrix. So what is the adjoint of a matrix, or how to calculate the adjoint of a matrix? See, if A be a matrix given by A equal to Aij, okay, it should be a square matrix in order to calculate the, okay, so let it be order n into n. Then the transpose of a matrix of cofactors of elements of A is called adjoint of A. Then what is adjoint of A? It is transpose of matrix of cofactors, transpose of matrix of cofactors of elements of given matrix. Okay, here our given matrix is A, and it is denoted by adjoint of, we denote it in small letters, adjoint of A. Okay, so how to calculate the adjoint of, if matrix A is Aij, then adjoint of matrix A will be Cij. Cij is the cofactor, and we have to take transpose. Order will be same, n into n. Okay, because it will be a square matrix. So if we take some matrix A as A equal to A11, A12, A13, A21, A22, A23, then A31, A32, A33. So this is a square matrix of order 3 into 3. Then adjoint of A will be, adjoint of A will be cofactors, transpose of cofactors. So first we need to calculate the transpose C11, C12, C13, C21, C22, C23, C31, C32 and C33. Okay, so we have to take transpose of this cofactors matrix, and it will be, see, C11, after taking transpose it will be C12, C13, then C21, C22, C23, C31, C32, and C33. C33. Okay, friends. So this will be adjoint of matrix A, and Cij is equal to Cij denotes the cofactors of Aij in matrix A. Okay. So how to calculate cofactors? This we have to understand. So formula of cofactors we can write if we are calculating cofactors for the A11. Okay. So we will write C11 is equal to minus 1 to the power I plus j. Okay, I is your, here in this case it will be 1. So I plus j, so 1 plus 1 it will become minus 1 to the power 2. And here see, if we are calculating cofactor of A11, we have to delete the row and column containing A11. So it will be A22, A23, A32, and A33. Okay. So it will become minus 1 to the power 1 plus 1 into, same thing we will write A22, A32, A23, and A33. Okay. This is equal to minus 1 to the power 2 will become 1, and when we open this determinant, so this will be A22 into A33 minus A32 into A23. Okay. So this is the value when we will remove A22 A33 minus A32 A23. Okay. Similarly, if we calculate, so first we will clear this, or I will clean the last line only. So this I will remove. So we have seen how to calculate C11. Next we will calculate C12. So C12 will become minus 1 to the power 1 plus 2. Okay. And 1 2 is here, so we will remove this row and second column. So we will have A21, A31, A23, and A33. So after calculating the value of determinant, see this minus 1 to the power 3 will become minus 1, and after multiplying we will have A21 into A33 minus A31 to A23. Okay. So this will be A31, A23 minus A21, A33. Okay, friends. Similarly, we will calculate cofactors for each element of A, and then a simple rule to write Aij you can understand. Cofactors, cofactors of Aij is equal to D. D is a determinant like this one. Okay, this is D. So D if I plus J is even integer. Okay, and minus D, if I plus j is odd integer. Okay friends, so we have understood what is cofactors and how to calculate the adjoint. Now we will take a problem based on this. So let's clean this. Find the adjoint of matrix of given matrix which is given by A equal to 1, 2, 3, 0, 5, 0, 2, 4, 3. Okay. So how to solve this? First we need to find the cofactor matrix. Let C be the cofactor matrix or matrix of cofactors which is given by C11, C12, C13. Then second row will be C21, C22, C23, C31, C32, C33. Okay. So how to calculate? We will calculate cofactors as C. For C11, if we see, it will be minus 1 to the power 1 plus 1 will be 2, and we have to delete first row and first column, then we will get 5 into 3, so 15 minus 4 into 0. Second C12, I plus j will be minus 1 to the power 3, and we will have 0 into 3, that will be 0, minus 2 into 0, 0. C13 is calculated as minus 1 to the power 4, and 0 into 4, 0, minus 5 into 2, 10. Similarly, for second row, C21 will be minus 1 to the power 2 plus 1, that is 3, and it will be 2 into 3, so 6 minus 4 into 3, 12. C22 will be minus 1 to the power 4, and 1 into 3, that is 3 minus 2 into 3, 6. C23 will be minus 1 to the power 5, and we will get C1 into 4, that is 4 minus 2 into 2. So again it is 4. Next C31 will be minus 1 to the power 4, and we will have 2 into 0, that is 0 minus 5 into 3, 15. Then C32 minus 1 to the power 5, and it will be 1 into 0, 0 minus 3 into 0, it will be 0 only. Next, minus 1 to the power 6, 3 plus 3, and this will be 1 into 5 minus 0 into 2. So our cofactor matrix will become, see, 15, this is 5 into 3, 15, and this minus for 0, so it will be 0. Next one will be minus 10. After that we will have 6 minus 12, minus 6 and minus 1 also, so it will be 6. 3 minus 6 minus 3, 4 minus 4, 0. 0 minus 15 will be minus 15. Then next one, 0 minus 0 will be 0, and 5 minus 0 will be 5. Okay friends. So this is our cofactor matrix, and adjoint of A So adjoint of A will be given by cofactor transpose, and it is equal to 15 0 minus 10 6 minus 3 0 minus 15 0 5, and transpose of this we have to calculate. So it will become 15 0 minus 10, then 6 minus 3 0, and third column will be minus 15 0 5. Okay friends, so this is the adjoint of given matrix A. Next we will see properties of adjoint matrix. So we will discuss properties of adjoint matrix. So what are the various properties of adjoint matrix? First one is, if A be a square matrix of order n, okay, if A be a square matrix of order n, okay, then A into adjoint of A will be same as adjoint of A into A, and we can write this also as modulus of matrix A or determinant of A into identity matrix of order n. Okay, so product of a matrix and its adjoint is commutative. Okay friends, second property is, if A and B are square matrix of order A, if A and B are a square matrix of order n, then adjoint of AB, adjoint of matrix AB will be equal to adjoint of matrix B, adjoint of B into adjoint of matrix A. Third property is, if A is a square matrix of order n, okay, A is a square matrix of order n, then adjoint of transpose of adjoint of A will be equal to adjoint of A transpose. Okay, transpose of adjoint of matrix A will be same as adjoint of A transpose. Fourth property is, if A be a square non-singular matrix of order n, if A be a square non-singular means determinant of A is not zero, non-singular matrix of order n, then adjoint of ad, adjoint of A, will write adjoint of A will be equal to determinant of A to the power n minus 2 into matrix A. Okay friends. Next property is, if A is a square non-singular matrix of order n, square non-singular matrix of order n, then adjoint of adjoint of A adjoint of A, we'll write it clearly, adjoint of adjoint of A and determinant of that matrix will be equal to determinant of A to the power n minus 1 whole square. Okay friends, so let's clean this and we will continue with properties. Properties continued. Okay, we will discuss property number 6. If A be a square matrix of order n, if A be a square matrix of order n and K is a scalar and K is a scalar, okay, then adjoint of K times A will be equal to K to the power n minus 1 into adjoint of matrix A. Next property is property 7. If A be a square matrix of order n, if A be a square matrix of order n and m is a natural number, then adjoint of A to the power m will be equal to adjoint of A whole to the power m. Okay friends. Next property 8 is, if A and B are two square matrices of order n, A and B are square matrices of order n such that B is the adjoint of A, B is the adjoint of A and K is a scalar, okay, then we have A into B plus K times of an identity matrix of order n, determinant of A into B plus K times of an identity matrix of order n will be equal to determinant of A plus K to the power n. Okay, friends. And last property is adjoint of a diagonal matrix is a diagonal matrix. Adjoint of a diagonal matrix is a diagonal matrix. Okay, this we can see. Example we will see if A 0 0, so non-diagonal elements will be 0 of a diagonal matrix. So 0 0 C. So diagonal elements are A, B, and C. If we calculate adjoint of matrix A, this is our matrix A. So adjoint of A will be, see, first one power even, so it will be positive. So A into BC, it will be BC. Second will be 0 0. Next will be see all the elements. This for B it will be A into C, and it will be C, this A into C, and this is 2 plus 2, so minus 1 to the power 4, it will be positive only. This will be AC, and third row, third column will be A into C, A into B. It will be A into B, and power will be minus 1 to the power 6 will be positive. Okay, friends. So this transpose, and when we take transpose of this, it will be same BC 0 0, then 0, second row will AC 0, and 0 0 AP. Okay, friends. So adjoint of a diagonal matrix will be a diagonal matrix. So next we will see how to calculate inverse of the matrix. Inverse of a matrix. Also we call it as reciprocal matrix. A reciprocal matrix. So how to calculate inverse? See, a square matrix A which is non-singular of order n will be invertible. Okay. If there exists a square matrix P of the same order such that AB is equal to IN. Okay, friends. So a square matrix A square non-singular matrix we will write non-singular matrix of order n is invertible if there exists a square matrix B of same order such that AB will be equal to IN, and same it will be BA. Okay. So product of A and B will be a identity matrix of same order n. So in this way, and the formula that will be A inverse is calculated as, it is denoted by A to the power minus 1 we calculate this as adjoint of A divided by determinant of matrix A, but determinant of A should not be 0. Okay, that is, it should be non-singular matrix provided determinant of A is not equal to 0. So in this way we can calculate the inverse of a matrix. Next, we will see properties of inverse of a matrix. So after properties, we will solve a problem based on this concept, how to calculate the inverse of a matrix. Okay. So properties of inverse of a matrix. Okay, friends. So what are various properties? First is every invertible matrix possesses a unique inverse. So every invertible matrix possesses a unique inverse. Second property is if A and B are invertible matrices of order n into n, then A, B is invertible. See, this first property is also called uniqueness of inverse. Uniqueness of inverse. Okay. Second property is called reversal law. Reversal law, which states that if A and B are invertible matrices of order n into n, then AB is invertible. Okay, and AB inverse will be equal to B inverse into A inverse. Okay, friends. So we will clear it and continue with properties. So third property is, here properties continue. Properties of inverse continued. Okay. Third property is if A be an invertible matrix of order n, then A transpose is also invertible and A transpose inverse of A transpose will be transpose of A inverse. Okay. Inverse of A transpose will be equal to transpose of A inverse. Okay, friends. So next property is if A be an invertible matrix of order n, A be an invertible matrix of order n and K is a scalar which is an element of natural number. Then a to the power k means inverse of a to the power k will be equal to a inverse to the power k, and it is equal to a to the power minus k. Okay friends, so next property fifth, if A be an invertible matrix, let A be an invertible matrix of order n, then inverse of A inverse will be equal to A. Okay friends, inverse of A inverse will be equal to A. We will discuss next property number 6. If A be an invertible matrix of order n, then A determinant of A inverse will be equal to 1 by determinant of A. Okay friends. So determinant of A inverse will be equal to 1 by determinant of A. Next property is, this is the last property, inverse of a non-singular diagonal matrix diagonal matrix is a diagonal matrix. Okay friends, so we have discussed all the properties of inverse of a matrix. Now we will solve problem based on inverse of a matrix. So let's take a problem. First we will calculate the inverse of a matrix. Find A inverse if matrix A is given as 0, 1, 2, 1, 2, 3 and 3, 1, 1. So we have to find A inverse. So how we will proceed here? First, A is the given matrix. So we will first find and calculate determinant of A, and we will check whether this is singular or non-singular matrix. 0, 1, 2, 1, 2, 3, 3, 1, 1. Okay friends. So it will be 0 into 2 minus 3 minus 1 into 1 minus 9 plus 2 into 1 minus 6. So it will be 0 minus plus 8 and minus 2 into 5, 10. Okay. So it is equal to minus 2, which is not equal to 0. So A is non-singular matrix, and we can calculate inverse using this formula. Okay. Now as we know, A inverse is given by adjoint of A divided by determinant of A. So next, as we have calculated determinant of A, next we have to find adjoint of A. And for calculating adjoint of A, we have to find first cofactor matrix. So cofactor matrix we will calculate as, say, 0, 2 into 1, 2 minus 3. So it will be minus 1, next minus 1 and 1 minus 9. So minus 8 and minus 1 plus 8. Next will be 2. Next is 3 plus 1, so positive only. And 1 minus 3 into 2, 6, so minus 5. Next element is 1 into 1 minus 2, so minus 1 and minus 1 to the power 3 will be 1. Okay, so all the elements will be minus 6, 3, 2 and minus 1. So this is a cofactor matrix, and adjoint of A will be transpose of cofactor matrix. So we will give this as minus 1, 8, minus 5, 1, minus 6, 1, minus 6 and 3. Next one is minus 1, 2 and minus 1. So we have calculated adjoint of A. Then A inverse. Okay. Therefore A inverse will be adjoint of A divided by determinant of A. So as we have calculated determinant as 1 by minus 2. Okay. And adjoint of A is minus 1, 1, minus 1, 8, minus 6, 2, minus 5, 3, minus 1. Next, what we have to do, we have to simply do scalar multiplication. So it will become minus 1 and minus 2. We will divide by minus 2, so it will be 1 by 2, minus 1 by 2, then 1 by 2, minus 4, 3, minus 1. Next will be 5 by 2, 3 by minus 2, so minus 3 by 2, and last will be minus 1, and minus 1 by minus 2 will be 1 by 2. So this is our A inverse. Okay friends, so this is how we calculate inverse of a square matrix. Okay friends, so today we have discussed how to calculate adjoint of a matrix, what are cofactors, we have seen properties of adjoint matrix, then we have discussed inverse of a matrix and properties of inverse of a matrix. I hope every one of you have understood this lecture. If you have any doubt or any query regarding this topic, please let me know in the comment box. I will try to resolve your doubts. Okay friends? And if you have seen the whole video and you liked it, please like the video and subscribe our channel Ahajindagi Edu-Care. Also press the bell icon button so that you will get notification when the next video will be uploaded. Okay friends, thank you.